Hi everyone, this is Miss Peters, and I'm going to go over another stoichiometry problem. This one is really good because it is percent yield. It's also limiting in an excess reagent problem, even though it doesn't say it. So let's look at it. In the commercial production of the element arsenic, arsenic 3 oxide is heated with carbon, which reduces the oxide to the metal according to the following equation. If 8.87 grams of arsenic 3 oxide and 26.33 grams of carbon are used in the reaction to produce 5.33 grams of arsenic, calculate the percent yield of the reaction. So first, we need to look at what is the formula for percent yield. So percent yield is like a way of testing, like what's my grade? You know, how much I should have made this much and I made this much. How does it compare? So the formula is actual yield, which is the amount from a lab divided by theoretical yield, which is the stoichiometry answer, how much should you have made, times 100, because it's a percent. And so looking at this problem, we've got an amount of reactant and another amount of reactant, and it says it makes that much product. That is my actual yield. Actual yield, unless if you're doing a lab, has to be given to you because you didn't do a lab. That is how much product was made. That's not necessarily my theoretical yield, which is how much should I have made. Theoretical yield comes from stoichiometry. Actual yield is what you do in a lab, or if it's a word problem, it has to be given. So first, let's balance this equation. So I've got 2 arsenics on the left and 1 on the right, but looking at this, oxygen is 3 on the left and 2 on the right. 3 and 2, I can't make 2 become 3, but their common factor is 6. So I can make them, both of the oxygens become 6 by putting a 2 in front of this and a 3 in front of the CO2. Now oxygen is 6, but that meant arsenic is 4 on the left, so I'm going to put a 4 in front of it on the right, and then carbon. I've got 3 carbons on the right, so a 3 right here, and that is balanced. So that's step 1. Okay, so now we know that's our actual yield. We'll worry about that later. Now we need to find the theoretical yield. And so without saying this is a limiting and an excess reagent problem, it is, because we've got 2 different amounts of reactants, and I did not tell you which reactant was limiting and which one is excess. And so what we're going to have to do is we're going to have to take that 8.87 grams of the arsenic oxide and change that to grams of arsenic. And then we're going to have to do another stoichiometry. We're at 26.33 grams of carbon and change that to grams of arsenic. And then whichever one is my smaller amount of arsenic, that is my theoretical yield, because that means that reactant was limiting. And we'll get to that in a minute. So this is kind of our game plan. We need to do this one first. We'll do this one second, and then we'll talk more about why we picked the smaller one later. So let's get started. Okay, so 8.87 grams of arsenic, 3 oxide. I'm starting with grams, so I need to change to moles first. You would go to the periodic table and add up 2 arsenics and 3 oxygens. And you're only going to add 2 arsenics and 3 oxygens. You don't double it because there's a 2 in front. Ignore the 2 when you do molar mass. And when you do that, you should get a molar mass around 197.841 grams are in a mole. Now we're at moles, so we need to use our mole ratio, which is our coefficients. And I'm solving for arsenic because the problem, my actual yield, was arsenic. So that's why I'm solving for arsenic and not carbon dioxide, because my actual yield is grams of arsenic. And so my mole ratio for AS2O3 is a 2. So I'm going to put that 2 moles As2O3 at the bottom, so that moles of that cancel out, and that equals moles of arsenic. So 4 moles As. And then we can solve for grams because we're going to need grams of arsenic to do our percent yield. So anytime it's grams, it's all, which you go to the periodic table, but it is always 1 mole. The only time you use coefficients from the equation are in your mole ratio, which is that step that I just boxed. Otherwise, it's always 1 mole. And the molar mass of arsenic is 74.922 grams. Okay, and then let's make sure all of our units cancel. Grams As2O3, grams As2O3, mole As2O3, mole As2O3. Mole As, moles of arsenic, and we're left with grams of arsenic. So now to type this in. And this one, be really careful when you type it in. Multiply across the top, multiply across the bottom, and then divide last. But you should get 6.72 grams of arsenic. So we're going to hold on to that number because we don't know that As2O3 is our limiting reactant. So we need to do another stoichiometry, as I said earlier, with the grams of carbon and solve for grams of arsenic. And then whichever number is smaller is my answer. So I'm just going to make a note that that made 6.72 grams of arsenic. But now we need to do another stoichiometry with the carbon number, as I said. So 26.33 grams of carbon. The molar mass of carbon is 12.011 grams of carbon in a mole. And then, now that I've canceled out grams, I am at moles, so I go to my coefficients and use my mole ratio. 3 moles of carbon to 4 moles of arsenic. Now, and then I made sure I put moles of carbon at the bottom of this, so those units canceled. And then we're going to solve for grams of arsenic. And again, when you go from mole to gram, it is always a 1 right here. The only time we use coefficient, mole ratio. And that was 74.922 grams of As. And then when we do that, we get about 219 grams when you type that into your calculator. So I've got 2 grams of arsenic, one that was 6.72 and one that was 219 grams. So my theoretical yield is 6.72 grams of arsenic. Because once this problem tells me that 8.87 grams of arsenic 2 oxide will make that much product. Once you make 6.72 grams of arsenic, you don't have any more arsenic 2 oxide. So this reaction can't keep going. You have run out of a reactant. So that means As2O3 was my limiting reactant. Because it is the one that's going to run out first. We have no more arsenic oxide to use. It's gone once you make those 6.72 grams. And carbon is my excess reactant. And so when you're doing any problem, the smaller amount of product is always how much you can make. Because again, once you run out of your limiting reactant can only make that much, 6.72 grams. So once you make that many grams, you have no more limiting reactant. Reaction can't happen. You need both reactants for the reaction to happen. That one's gone. So you always pick the smaller amount of product as your theoretical yield, not the bigger number. And so, coming to this question, percent yield again is actual over theoretical times 100. Actual yield is how much you got in a lab. Because we didn't do a lab, this is a word problem, it's that 5.33 grams divided by theoretical, my stoichiometry answer, 6.72 grams times 100. And that gives us about 79.4 0.3% yield. So not terrible, not amazing. They should have made more product and they didn't. That would be due to lab error or whatever. I hope this video was helpful in explaining limiting and excess reagents and percent yield.